Okay, before we go to the selection sort, I just would like to show you some piece of code that I just added. So this is our bubble sort that we used to do. This is where the bubble sort actually is happening, right? And you know what, let me just put this as a comment for now. So this bubble sort here, basically, this is where the code, this is where I'm going to do the sorting. Now what I can do, basically, I can just take this and put it into a method that is static and put that code there. I just need to call it here and that's it. I mean, this is just doing exactly the same thing again, before and then after, but this time with the bubble sort, because I do the bubble sort. The advantage is that I can create another method for the selection sort and then I can just compare them. Now what I'd like to show is this, basically, because this is why I put that into a method, because it will make easy for us to understand what we're doing. So what we do is that we use this static method, nanotime. Nanotime is 1/1000th of a second, so it's kind of very accurate to a billionth of a second. So we just remember the time just before we start the bubble sort, and then we remember the time just after we finish with the bubble sort. So we have this, the start time and end time, which are counted as a long, which is an integer number but is kind of long. So every second, not even millisecond, it's nanosecond, it's 1/1000th of a second is going to be covered here. Now the thing is, once I have these two, I can just have this end minus start. Why end minus start and not start minus end? Well, because the end is, the time goes up, so I need just to take the bigger time and subtract the smaller time so I can see the difference. If I flip them, it will be negative. And then I divide that by 1 billion. There are 9 zeros there. That's 1/1000th of a second. To get that in seconds, I just would like to have how many seconds. And now I'm doing this printf, if you remember, just to be able to do something like this. So I can see, I can control how many values after the second. Because if I don't do that, I'll get some kind of, let's just print ln the same way we used to do. And of course I need a plus here. Anyways, regardless of the formatting, if I run this thing, you see, I get a number like this, because it's so small that it's 4.10 of the power minus 6. So I don't want to see that. I just would like to see some decimal values. So I'll just put this, for example, as 7 or 5 or whatever. Now when I run this, it tells me exactly how many seconds it took to finish this bubble sort with, because now I have only 10. Now if I make it 100, it will take slightly more. And you guessed it, put more, you get more. So it increases. It will take, but you see, it's kind of impressive how fast it does this processing with 1,000 numbers. You see, there's 1,000 numbers. It flips them so many times. It repeats 1,000 times, 999 times. That's a lot of repetitions, but they're done so fast. It's not even reaching 1 millisecond. It's half of a millisecond. Now if I'd like to see some seconds there, I need to make it a big number. So to make something like this, for example, but I'm still even not reaching a second. This is 10,000. So 100,000, it becomes to do something. But the problem here is not about the calculation, it's just the display. The display is taking time. Displaying this 100,000 is taking a lot of time. Not the thing. The proof of that is that if I remove this display and display, which I'm not displaying the array, I just would like to see the time now. If I run it, well, no, it was also the, so it takes sometime. I was thinking maybe the display was delaying us, but it wasn't. So this is with 100,000. So it's still running. No, it's stopped. So it's 15 seconds, 0.9. Just to sort this 100,000. Now the thing is, I'm going to be able to compare that with the other one by just putting another method that is going to be the selection sort, and then compare that. But the idea is use the system.nanotime. It's available like in the system.out. Instead of the out is the nanotime, and then you remember where it starts, when it stops, and then you divide to get the difference. That's your time, and then you divide it by 1 billion to get it in seconds. Now what we'd like to do is this selection sort. So the selection sort, we said, like, what we need to do is to find the maximum, and then by comparing 2 by 2, if we find the maximum, we just remember it, and then we keep going looking for the maximum in the array until we find it and we've reached the whole array. Once we're done, we're just going to be replacing the place with the maximum with the last one, and then we do it again, but this time finding the maximum in a smaller array, because now we know that the maximum is at its place. We need to find the second maximum to put it at its place again. So it's like finding the maximum many times. So that's what we're going to be doing. So let's find the maximum, and let me just do this faster. So we're going to be getting every time, just notice that every time we start, the maximum is always the first one. We assume that the maximum is the first one, so we just keep going. Okay, so let's just stop this. We don't need this anymore, and go back here. Now what I'm going to do, I'm just going to leave this here. I don't need the bubble sort for now, and I would like to display things to be able to see the selection sort, and make it just a smaller number, so it will be easier for us to make sure that it works. So now I'm going to do some code here for the selection sort. So the selection sort, I need to do the same thing, find the maximum, right? So if I need to find the maximum, I'm going to assume that all the time, you see, every time when we start, we assume that the maximum is the first one. So the element at position 0, the first element is the element at position 0, so I'm assuming that this is my maximum. And then what I'm doing, I need to compare the maximum with the next one, right? So in order for me to compare that with the next one, should I start from 0? I can start from 1, because I'm going to compare the maximum, the 0, with the next one. If you put 0, what you're doing is just comparing the maximum with itself, and it's going to be false, and you just have just one iteration that is useless. Now by starting with 1, I just start immediately with what I need to do. And of course I'm going to start at array.length, right? Because I start here, and then the last value that I need to compare with is the last one. So I'm finishing here. Now what I need to do is to find the maximum. Now it's the code to find the maximum is if array of max is smaller than array of I, which means I is actually should be the maximum. So the maximum should be I now. Right? That's how we find the maximum in the array. Now that I've found the maximum, what I should do? I've finished, everything is done. I found the maximum. I should swap that maximum with the last element. This is my I found the maximum. Now what I need to do is that the maximum should be the last one here. So what I need to do is just to take this and swap it with the maximum. What's the
Shouldn't be the array with length minus 1?
What do you mean? This one?
Yeah.
No. Because if the last value would be what? The last value of I would be what? Based on this thing. The array length is 10. The last value of I is 9. So let's make it 16 so we get the same thing again. So now last value, anyways, that's not what I wanted to. The last value of this now becomes, because the array.length is 16, the last value of I will be 15. So I would like to be, when I find the maximum, I need to check this one. If I put -1, I'm not going to be comparing my maximum with this one. And look, if in this case, for example, this one seems to be the maximum. If I stop here, it will just stop, compare up to here, and find that maybe this one is the maximum. It will put it here. So it's not going to work. Yes?
Why are you assigning max with the position of the biggest position?
Why do we assign max of the position of the... I don't get your question.
Max equals I.
Here?
Assigning max with the position of the biggest.
Yes, because this 0 here means what? The value of the array? No, this is the position. When I say max equals 0, that means I'm assuming that the first element is the maximum. This is how we start. The first element is the maximum. I'm not looking at the value of the maximum, just the first element. That's why I'm using here this as an index. You see, this max is the index of the maximum, not the max value itself. Yes?
If we want to start from 0 and we put array I plus 1, is it going to have a...
No, if you just put 0, yes, it will be +1, yes, it will give you an exception.
Plus 1 down, not
It will give you an exception as well. Yes. Because now the last value of I will be 15, and this 15 plus 1 will give you 16, which is going to raise the exception. So now we found the position of the maximum, which is either the first one, or when we find the better one, we just remember that position. Now the last thing that we need to do is to swap the maximum to put it at the last one. So I need to have this temp again, and then let's say array of max, I put it in the temp, then array of max is going to be array of I. No, there's no I now outside. I'm outside of the 4, so I doesn't exist anymore. Array.length, array.length -1, because if I keep it array.length, it's going to be giving me an exception, because array.length is 16 and the last index is array.length -1. Then array.length I should have copied it. -1 is going to be my temp. This is just the swapping. Now here I'm swapping the max with the last one. That's what I'm doing here. Just take the max, put it in temp. Now whatever was in the last element, just put it in the place of the max, and whatever was in the max, because I said it in temp, just put it in the end. Now just by finishing this, I just found the max and I put it at the back. Let's just run this.
change the 0. I of equal 1.
Which one?
I is equal 1.
The value is equal to 1?
I
Which line?
is equal to 1. Line
Oh yes, here. Yeah. Yes. If I put it 0, it's not going to give me anything wrong. I'm just doing some loop for an iteration for nothing. But that's better to know what you're doing when you put this one here. Now you see, the biggest value is 98, and that's the one that I find at the end. Now copy paste, but this time, yes. Sorry?
I equal 1 in the loop.
Yes. What's the question? Let's just see. If I put 0, now max is 0, I is 0. Array of max, right? What is array of max? We said max is 0, right? What is max? I'd like you to answer the question. What is max? Please. What is max? No, it's 0. So I put 0 in max, right? And then I put 0 in I. Now I'm asking, is array of max less than array of I? So what is max? It's 0. So I'm asking, is array of 0 is less than array of 0? I'm just comparing the same number. Why would I do that? I'm just comparing 49. Is it less than 49? Well, of course it will never be less than 49. It's the same number. You're comparing the same element. So what we should do, not compare this 49 with the next one. So that's why instead of making I starts from 0, we make it start from 1. That's why the first time I'm going to do this. I'm comparing array of 0 with array of 1, which makes sense. That's what I'd like to do. That's why I'm just keeping it like this with the one that's better. But if you make it 0, what would be? Is it going to make the program not work? No, it will work. It's just the first time it will just compare this. This will be false, and then I becomes 1, and then now this is where the job starts to work. But what I did is just the first iteration when I was 0 is just a waste of time for the computer. That's what I meant. Now that I have done this, the next step is to start again. Now this time, not for the last one, but the one before the last. Now I just copied and pasted, just next iteration, next step, let's say. Now this is a problem because I already have the variable. I don't need to declare it again. But should I put it back to 0? Yes. This is important because if I remove the whole thing, the max is going to stay where it was at some kind of position inside of the array, and then I'm going to be completely confusing my method. So every time, even though when I find the maximum, I put it at the back, I start again from the beginning. Let's just run. I always start from the beginning. So that's why I'm going to always make the max go back to 0. Then I'm going to do the same thing. Is it though? Am I going to go until array.length? Exactly, now it becomes -1. And then I'm going to do exactly the same thing. When I found it, well, I don't need to declare temp again. I'm just going to do this. But this time, am I going to swap this with array.length -1? It should be -2. Because it's not the last one, the one before the last. I just found the last one. I need the one before the last. So the last one is array.length -1. The one before the last is array.length -2. That's the position of the.
So we can do this in another way.
So this is, now we can see the loop. Yeah. Now let's just see that it's working, and then we have the second largest also at its place. So there's 94. And then just to make sure that we understand it, let's just make another step, and then we make the loop. Now if I just copy and paste, put some space. Now this is the next step, which is, again, we keep this as it is. Now instead of -1, it's -2. Now I'm just going to do it manually, then I'm going to make a loop. Then instead of -2, it's -3, and that's all I need to change. Now you notice that I need to change two things. This one here, and this one here. And then this is now the third largest is at its place. Okay, let's make a loop now. If I'd like to make a loop, it should be an outer loop for what? I'm just going to do for int, let's say n, starting from what? See, the first time I'm subtracting what from this array? No. You see, the first time, this is my loop. This is this loop. Look at this. This is the first iteration. This is the second one, and this is the third one. Sorry, the third one is this one. So check this loop. So the first time, for the 4, it's like -0. The second time it's -1, and then it's -2. So that's why I need to have something that starts, where's my 4? This one. Something that starts from 0, because now I'll need this to be n. Now if this is n, if it was 0, this is going to be n plus 1. No, what was it before? It was -1. What should I make the +1? So I'm having this, I'm always having -n. Now this time I have -n minus 1. The first time is 0, so the next time when n becomes 1, this becomes -2. That's what I want.
Can we do between parentheses?
Well, you can do between parentheses, but it doesn't make any difference.
N plus 1.
Yes, then if you would like to do that, yes, you need to, yeah, the other option is to, if you'd like to use the n plus 1, then it has to be between parentheses, yes. Now this becomes 0 plus 1 minus, which becomes -1. Now 1 plus 1 becomes 2, and then -2, yes. You can, anyways. Now this is my n, so it starts from 0, and n is less than what? What's the array dot length? Hold on, I just put a comma at the wrong place, and then n plus plus. Then this is where the loop starts, and this is where it ends. Well, I just need to also, whatever the number is here, it should be the same one here. So that's why I need to put this. So now I can remove these ones, these steps. Next step, swapping, and then next step, and then swapping. I don't need them again. Now just need to make sure that everything is working as expected. So the first time n is 0, so it will be array dot length, so it means the last one. And then I'm going to compare the last position, which is 0 plus 1, that will be array dot length minus 1, and then this is the same number that I'm putting here. And that should be working, my thing, to be sorting the whole array from smallest to largest. Again, now if I would like it to be like descending order from the largest to the smallest, just change this. But actually this is not the max, actually it becomes the min. Actually, to be more specific, now this is the, I'm looking for the minimum, and then I'm putting it at the end. So that's what I'm doing now. So that's the only difference between the two. So what I'm going to do now, take this, put it into a method, because I just would like to be able to compare. So this is selection sort. It just needs the array, and that's it. I need to create the method, and that's it, because it just takes the array. When you give it the array, it's just going to do its job. Now this is in descending order, or it doesn't matter. Let's just put it back in ascending order, and just this, put it back like this, and then it's going to be fun to just rename this, because it's better to be consistent. Now this is, I'm going to execute this bubble sort first, and then I'm going to count the start and end and display the results. So I don't want to display now. I don't need to display this because I don't want to display. I'm just going to say bubble sort, and then I don't care about displaying things. And this is the result of the bubble sort, and then I'm going to basically copy the whole thing and make a selection sort with this thing. Okay, of course I don't need to declare them again, they're there, I just need to use them, and this is going to be the selection sort. Now selection sort, so it will start with the bubble sort. First of all, it will just initialize everything, do the bubble sort, just display this is the bubble sort, just do the calculations, do the sorting, and then it will stop. We don't need to have this after, and then it will just display the elapsed time. Then it will start again with the selection sort. Just remember where it starts, and then do the sorting, and then remember where it stops, and display the elapsed time. Now what I'm going to do is just to run them and see this is the elapsed time for the bubble sort and the selection sort. Interestingly enough, this is for a small number of the array. I can see that the bubble sort is much faster. Can you see that? Now let's increase the size of the array and make it 1000. Now, but 1000, it becomes to be a difference. If it's a small array, I'm seeing that, well, fairly almost the same, or I don't know. But this is much slower, as you can see, as the bubble sort. So the bubble sort seems to be kind of nice with the smaller, or very small arrays, but as soon as they become a little bit bigger, I mean the selection sort is kind of faster. Now with 50,000, it's taking 4 seconds, and check that, 1 second. The same array, but is it really the same array? Now I'm doing something wrong here. That's not going to help me get the results. You know what am I do? What's the thing that I'm doing wrong? Now I generated the array, then I sorted with the bubble sort. Then I run the array, the sorting again. Yes. But the array is already sorted, so it's just not doing like a good comparison now. If I'd like to compare them, they should be exactly the same array, and then generate it again. So what I'm going to do now, I'm going to copy. I'm going to create another array this time. So array 2, and I'm going to generate the same thing. I mean, basically it's going to be the same value. So I generate only one random number, but I put it in 2 places. So this array 2 is what I'm going to use now to sort the selection sort, because if I'm using the same array, the first sorting is going to sort it, so I don't want it to be sorted. Now let's just make some real comparisons. Now let's just start with small number. Now you know it's just because it's I'm going to set the size like a variable, so I can change only that variable. It will be much easier for me. So it's final int size, and it's 10. Now if I run this, I can see that still the bubble sort is faster when it's for the small size. But if it becomes bigger, now it's taking four seconds and then 1 second again. So you can see that the selection sort is kind of faster when we have some kind of relatively bigger array. So that's how you can compare.